Welcome to Tarrant County College's Fire Service Training Center, Aerial Operations, continuing education class. All materials and slides come from IFSTA's Pumping and Aerial Apparatus Driver Operator Handbook, 3rd edition. SOPs help establish orderly aerial apparatus placement at incidents. Generally, SOPs apply to aerial apparatus assigned to initial response and later arriving aerial apparatus at large incidents, positioned according to Incident Action Plan. In many cases, apparatus placement procedures should be developed during pre-incident planning. During pre-incident planning for target hazards, personnel should give special considerations to aerial apparatus in terms of access to various portions of the occupancy, overhead obstructions, other factors that may influence function of the apparatus. Information can be used to determine best positions for aerial apparatus depending on the conditions at the incident. Many different procedures for positioning aerial apparatus assigned to initial response, including following 3 examples. When 2 aerial apparatuses respond to a given location, first arriving aerial takes front of the building and second goes to the rear or side depending on building access. When 2 aerials respond to a given location, first aerial positions based on present conditions, second aerial apparatus stages 1 block away or in accordance with departmental SOP and waits and instructions, or when single aerial apparatus responds to a given location, apparatus takes a strategically sound location in front of the fire building unless otherwise directed by the incident commander. Some fire departments establish a SOP about apparatus placement based upon height of building at scene. Driver operators can use the SOP to know where to properly position apparatus if the driver is the first to arrive at scene. Each department must develop SOPs, pre-incident plans that suit local conditions. Once developed, driver operators must be trained to follow SOPs on every response. For any given situation, proper distance between objects and aerial apparatus is the distance that affords maximum stability, best climbing angle, adequate extension. The distance should be consistent with ladders' planned use and conditions at emergency scene. Long extensions at low angles place maximum amount of stress on an aerial device and in some cases reduce its load carrying capabilities. Whenever possible, the driver operator should avoid long extensions at low angles by getting as close to the desired object as safely possible. The condition of the fire building affects the distance the aerial device may be positioned from the building. It's not advisable to park in the building's collapse zone if the building has been exposed to severe fire conditions or has otherwise been weakened. Spotting is the positioning the apparatus in a location that provides utmost efficiency for operating on the fire ground. The driver operator must consider surface conditions when spotting the apparatus. Only as a last alternative should apparatus be parked on soft surfaces. If working on soft surfaces, operators must be aware of and watching for settling. Stabilizer pads supplied with the apparatus must be used whenever stabilizers are deployed. The driver operator must be alert for stable surfaces when incident begins, but which may become unstable as the incident progresses. Frozen soil may be a stable surface as long as it stays frozen. Apparatus exhaust and warm water from the firefighting operations may cause the ground to thaw and become unstable. During warm weather operations, dry, solid ground can become unstable from fire ground runoff. Thin shaved pavement, common in parking lots, may also be dangerous as soft soil. Most parking lots are not constructed with the same strength reinforcement techniques and materials as public roadways. Parking lot or private driveways may consist of mere and thin layer of asphalt applied over dirt or minimal gravel base. Thin surface may not provide a stable enough base for apparatus stabilizers. If stabilizer pads or cribbing are not placed underneath the stabilizer's shoe, stabilizers may puncture parking lot surfaces, causing the truck to sink and possibly even tip over when the aerial device is operated to the side of the truck. Pre-incident plans should identify parking lots with potential for stabilization problems. The driver-operator must be aware of areas that may contain surfaces that cover underground vaults. Vault surfaces may be created by underground parking structures, utility chases, drainage culverts, basements that extend under sidewalks, underground transportation systems. Manhole covers are good indicators of underground voids. Some surfaces are engineered to withstand the use of aerial devices and others are not. Throughout the pre-incident planning, the driver-operator must be familiar with locations where they deploy stabilizers that could possibly punch through the surface and cause the apparatus to tip over. If the operator is unsure of the surface, then they should err on the side of caution. Hot surfaces, primarily spotting considerations associated with hot weather is extreme heat may tend to weaken marginally or otherwise firm pavement surfaces. Asphalt parking lots that may otherwise provide an adequate level of support during moderate temperatures may become soft during extreme heat and may result in unstable base. The visual indicator of a compromised asphalt surface due to extreme heat could be bleeding, thinning, shining, and look glassy. Positioning of the apparatus on a grade will have a certain tactical impact. Positioning with the front of the apparatus uphill, with the rear tires off the ground, the truck has less resistance to sliding down the hill. Rear compartments may be difficult to be reached once the apparatus is leveled. Positioning the apparatus with the rear of the apparatus uphill, it's easier to reach the ground with a platform operating off the rear of the apparatus. It's more likely that the front tires will be lifted off the ground, causing the frame rails to sag and make the device more difficult to stow properly after operations are complete. Depending on operational capabilities of the apparatus and severity of the grade, apparatus with two rear jacks may need to face uphill. By facing uphill, angle of the turntable is decreased, thereby increasing capability of and stability. If the apparatus is facing downhill, capability of the apparatus is decreased. In some cases, it's possible to level the truck somewhat by using stabilizers to raise one side of the truck more than the other. Generally, only possible on grades perpendicular to the long center line of the apparatus. Ability to do so depends on the type of stabilizer which the truck is equipped with. For most part, can only be done with single chassis vehicles designed to be lifted completely off the ground. Moderate to high winds impose a dynamic load on the aerial device, which may reduce the overall stability by forcing movement for which the apparatus was not designed for. Movement by wind also magnifies other loads placed on the device by personnel and equipment. When necessary to operate during high wind conditions, the driver-operator should spot the apparatus in a manner that minimizes extension needed. Aerial devices may be positioned over the front or rear of the apparatus, preferably parallel to the wind direction. Driver operators and company officers should also be aware of the weather phenomenon caused by buildings such as wind tunnels, avoiding them whenever possible. The driver operator should also adhere to manufacturers' recommendations for operations in windy conditions. Manufacturers have a determined maximum wind speed recommendation for their apparatus, may or may not be indicative on a load chart. Electrical hazards create a serious threat to aerial apparatus. Since they are much larger than other fire apparatus, aerial apparatus driver operators must be cognizant of the vehicle's surroundings. If possible, the driver operator should avoid spotting apparatus in a position that will require a lot of aerial device maneuvering around ground and overhead obstructions. When positioning aerial apparatus, the driver operator should avoid parked vehicles, trash containers, and similar obstructions. In certain circumstances, the ground around a down power line or charged vehicle may become electrically energized. Ground becomes charged in a concentric circle with varying voltage potential. Straddling these bands can result in serious injury or death as current passes through your body. Stay away from vehicles or power lines. Keep both feet on the ground at the same time. This will prevent you from becoming a conductor between two areas of the ground that are currently charged. It's just as important to look up as it is to look at the ground. The aerial apparatus operator must continually be aware of the overhead power lines and their conditions as the fire progresses. Some guidelines when working in the vicinity of power lines. Make sure the work area is clear of major obstacles and overhead obstructions. Maintain clearance from all overhead power lines per your standard operating procedures. Do not work within 50 feet of high voltage transmission lines. High tension wires that transport electricity over long distances. Higher than lower voltage lines, but will still be within reach of the aerial platform or aerial device. Interview representatives in your area and learn to recognize the differences. Look up and live. Always check the operating vicinity for power lines before you drive into it. In many cases, principles of spotting aerial apparatus are linked with stabilizing the apparatus. Stability of the aerial apparatus can be improved by operating aerial device in line with the longitudinal axis or the apparatus body. Apparatus is most stable when the aerial device is operated directly over the front or rear of the vehicle. Increasing the angle of the aerial device away from the longitudinal axis of the truck decreases load weight that can be carried safely. Angle perpendicular to the apparatus is the least stable position. By positioning the truck body in line with the expected position of the aerial use, stability of the apparatus can be increased. Stress in aerial devices, factors that work against aerial devices' strength. Strength may be imposed in both static, which is at rest, and dynamic, which is in motion operation. Stress tends to be greater when the aerial device is in motion. Aerial device load capabilities vary from truck to truck and must be evaluated on an individual basis to determine the range of safe operation. The driver operator should adhere to manufacturer's recommendations for maximum loading information. Aerial device stress can occur from one or a combination of the following conditions: excessive degree of angle, both horizontal and vertical, measured from the truck's center line axis, operation of non-parallel positions, uphill, downhill, or lateral grades, operation in supported tip versus unsupported tip positions, length of the aerial device extension, nozzle reaction from elevated master streams, weight and/or movement of hose, water, personnel, and/or equipment on the aerial device, wind reaction, improper operation of the aerial device, sudden starts, stops, rough operations of hydraulic controls, heat exposure, which could be radiant or convection, ice on the ladder or platform, impact with the building or other objects, improper stabilization, wear caused by road travel. Stress is increased when ladder rungs are operated non-parallel to the ground or when apparatus is parked on an incline and the aerial device must be operated off the side of the apparatus. These positions and other like them create torsion or twisting action on the ladder or the boom and the turntable. When the apparatus must operate off of an incline, the driver operator can reduce these stresses by spotting the turntable downhill from point of operation. When approaching uphill, the apparatus should park past the building and operate the aerial device from the rear of the truck. When approaching from the downhill side, the apparatus should be stopped short of the building. The aerial should be operated over the cab. Ideally, the truck should be operated in the uphill position with the aerial device directly in line to reduce the stress. Consider whether your apparatus or device is designed to operate in a position that is unsupported or supported. All driver operators should consider the following. Exercise caution when navigating through the vehicle and pedestrian traffic. Be aware of narrow and one-way streets and alleys. Always approach incidents from upwind and uphill when possible. Place the apparatus in a position that minimizes the angle and extension to which the aerial device will be raised. Driver operators should also consider if their apparatus is to be positioned in a dead-end access. Backing the apparatus into position, if possible, will make an escape faster if it becomes necessary. Avoid spotting apparatus in a location that will require the apparatus to be stabilized on top of debris or otherwise unstable surfaces. Park apparatus in a manner that does not block other apparatus that need to be closer to work in the area. Do not park so far away it is difficult to carry ground ladders and other portable equipment to rescue scene if necessary. Do not block scene's access to late arriving fire vehicles. Avoid parking in a position where the apparatus exhaust fumes, noise, vibrations will affect victims and rescuers. Shut the engine down if apparatus is used solely for providing additional support personnel. Traffic cones should be placed to direct traffic away from the apparatus and/or the incident. Another consideration for the driver operator is to locate a suitable water supply. Not always possible, since there may be limited availability on the roadways, in rural areas, and at other incidents. Hydrant placement on highways may be infrequent or non-existent. May be necessary to stretch hose lines or use an aerial device from an overpass or underpass to get water to the level of the highway. Often, aerial apparatus placement at scenes of a fire or medical incident is limited by order in which responding apparatus arrive. Later arriving apparatus may be blocked from a better position by an earlier arriving engine or rescue vehicle. SOPs governing apparatus placement are one way to prevent this type of situation from occurring. Follow these guidelines if the apparatus is required to position on or operate from a bridge. Be alert of the wind conditions. Recognize that large bridges are designed to move somewhat in response to force placed upon them. Remember, bridges will be the first section of the road to freeze during cold weather conditions. Aerial apparatus often respond to structural incidents. Positioning is determined based off concerns such as building height and condition, as well as the following immediate functions needed from the apparatus: rescue, ventilation, elevated master stream. Intensity of the fire may also dictate placement of the apparatus. Large hot fires indicate placement of apparatus must be further away from the fire building, especially if the building has been noted to be a safety risk. Consideration must also be given to fire's potential growth. When spotting apparatus at fire incidents, be aware of falling debris: parapet walls, awnings, concrete blocks, steel gates, roof-mounted signs, large pieces of glass. Building instability is the reason apparatus should not be parked in the collapse zone. Please make sure that you are at least 1.5 times the height of the building away from the structure. There are many indicators that a building might become unstable: bulging walls, sagging roofs, large cracks in the exterior walls, falling bricks, blocks, or mortar, and interior collapse of the structure. Keep in mind these considerations when responding to a potential hazardous materials emergency with an aerial device. Obtain information on wind speed and direction while en route. Approach the incident from upwind and uphill if possible. Stop short of the incident scene until the nature of the hazard is understood. Potential exposure to high levels of heat. Do not park over manholes or storm drains. If materials involved is corrosive, any contact with the aerial device will result in damage. When parked with aerial device in its stowed position, apparatus has a center of gravity located somewhere along the longitudinal midline of the chassis between the front and rear axles. If the aerial device is deployed without first setting apparatus stabilizers, the base of stability is limited to rectangular formed at each corner of the tires of the apparatus. Limited base of stability is undesirable because of the inherent flexibility of the suspension and tires. Deploying the stabilizers increase the base of stability. Extending the aerial device straight over the front of the apparatus will cause a corresponding forward shift in center of gravity. Rotating the device 360 degrees will trace a gravity circle as long as the gravity circle does not extend outside the base of stability. Apparatus should remain stable. The gravity circle extends beyond the base of the stability on the short jack side, indicating extending aerial device. On the short jack side will likely overturn the apparatus. Lateral grades may also have an adverse effect on stability of the apparatus. If the apparatus is parked on a lateral grade, center of gravity will be shifted to the lower side. If the aerial device is raised over the low side, gravity circle may extend beyond the base of the stability. Overloading the aerial device can also have an adverse effect on stability of the apparatus, even on a level surface with stabilizers fully deployed. Excessive loading on the aerial device will result in an expansion of the gravity circle. In some cases, the gravity circle may extend beyond the base of stability, particular to either side of the apparatus. There are many types of stabilizing devices available, depending on the type, size, configuration of the aerial apparatus. Post-type stabilizers, also called downriggers, are straight jacks that extend down from the chassis. Box stabilizers, also called H-stabilizers, stabilize that extended straight away from the truck and have jacks that extend straight down to the ground. A-frame, scissor, or X-style stabilizers, also called fulcrum type stabilizers, stabilizers that extend down and away from the chassis at an angle. To deploy the stabilizers and the aerial device, it's necessary to engage the hydraulic system. The driver operator must activate the power takeoff, or PTO, or other specialized hydraulic system. The PTO system provides power to hydraulic pump, which in turn creates a pressure on the fluid in the hydraulic system. Driver operator should not engage the PTO until the aerial apparatus has been properly positioned in accordance with the conditions on the incident. The process of engaging the PTO is fairly similar for all types of aerial apparatus. The engagement switch for the PTO or hydraulic system is usually located on the dash of the vehicle between the driver and passenger or officer seat. In switch panel overhead of the driver's seat. Type of PTO activation switch varies from manufacturer to manufacturer. They may be pneumatic, electric, hydraulic, or a combination of these. Procedures for engaging and disengaging PTOs on aerial apparatus depend upon what type of transmission the apparatus has, whether or not the apparatus is equipped with a fire pump, whether or not the apparatus has an automatic transmission with a fire pump, a manual transmission without a fire pump, an automatic transmission with a fire pump in use, or a manual transmission with the fire pump in use. Most newer models of aerial apparatus are equipped with what is called a hot shift PTO system, acceptable to engage these systems when the main transmission is in neutral. This should only be done when the driver operator is sure the vehicle is equipped with such a system. Attempting to engage a PTO from neutral in a vehicle not equipped with a hot shift system could result in serious damage to the PTO and main transmission. Whenever possible, position the aerial device before activating the pump. When the fire pump is already active and in use, the hydraulic system needs to be activated later, necessarily to lower the engine speed to near idle prior to engaging the hydraulic system, PTO, or other device. This action will lower water supply to nozzles. The operator must notify personnel on hand lines and other nozzles of what is taking place. The process of setting the stabilizers should begin with both the officer and the driver assessing the area of setup. Once the area has been determined to be safe and appropriate for stabilization, the driver operator can engage the PTO system and begin actual deployment of the stabilizers and the aerial device. First, make quick observation to avoid potential problems. If not automatically accomplished, activate the front brake lock to minimize longitudinal movement of the chassis. Make sure the PTO is engaged and the light is illuminated before leaving the cab. Chock the wheels. Follow SOP manufacturer's recommendation as to which wheels that should be chocked. Next, anticipate the path of travel of the stabilizer as they deploy to be sure they do not strike or land on other objects. The driver operator should be observant of the following obstructions: other vehicles, utility poles, hose lines, fences, signs, and other personnel operating on the incident. If there's any doubt as to whether or not there's enough room for the stabilizers to deploy, a short pike pole, closet hook, or arm span can be used to estimate the path of the travel of the stabilizers. Whenever possible, a spotter should assist the driver operator with positioning the apparatus because a spotter can help avoid curbs, manholes, vehicles. If possible, position a second firefighter in the area of the stabilizer deployment to keep people away from the stabilizers in the contact zone. The driver operator should move following objects, ensure stabilizer shoe contact areas are as stable as possible: large rocks, fire hose, tools, underground utility access covers, and broken pavement. Once the driver operator is assured primarily activities are successfully completed and ground is prepared for stabilization activities, so the selector valve may be operated to provide hydraulic power to the stabilization system. The selector valve could be located on either rear step area or midship on the driver's side of the apparatus. Physical operation of the selector valve varies depending on the manufacturer. Controls should be clearly marked as to proper positions for each operation according to the manufacturer's directions. The driver operator should make certain that the controls is in stabilization position, also called the outrigger, jack, or leveling position. On some makes of apparatus, operations of the selector valve automatically releases the aerial device bed locks. When the selector valve control moved to the proper position, apparatus is ready for stabilization to begin. Level terrain is the ideal location to stabilize an aerial apparatus. Even terrain allows for maximum stability of the apparatus and the greatest range of safe movement of the aerial device. Stabilization controls are typically found on the rear step area of the apparatus. Some manufacturers locate these controls midship on one or both sides of the vehicle. Generally, one set of controls for each of the stabilizers. The driver operator can operate more than one control at a time. Before operation begins, the driver operator should be aware of the following general principles of the stabilizer controls. Many of these controls are lever-type valves that move up to about 90 degrees. Operating these controls will automatically regulate the engine idle speed. Fast idle toggle switch or manual throttle control may also regulate engine idle speed. This provides power necessary to perform the desired action. When the driver operator operates the control, increases in engine speed occurs. Operation of these valves also affect vehicle's engine speed. Avoid rough or jerky operation of the valves. Box stabilizers are the most common stabilizers used on newer apparatus. Basically, there's two-part devices. An arm, which extends straight out from the side of the truck parallel to the ground. Attached to the end of this extension arm is a stabilizing jack that extends down to the ground to raise the vehicle. When operating this type of stabilizer, first operate is to extend the parallel extension arm to the maximum travel distance if possible. When extension arms have been extended to their final position, portable stabilizer pads should be centered beneath the stabilizer shoe so that they will be in position when the jacks are lowered. Stabilizer pads, usually provided by the manufacturer of the apparatus, are usually 24 by 24 with a built-in handle or rope of some sort. Each stabilizer pad or positioned stabilizer jacks may be lowered onto them. As stabilizers are being lowered, the driver operator should be looking at contact area to the certain pad are properly positioned. When operating on level ground, it makes no difference which side is lowered first. The driver operator should lower both stabilizers on one side of the vehicle. Follow the manufacturer's instructions on how to determine when the stabilizers are properly deployed. Due to potential for chassis and torque box damage, one stabilizer should never be fully activated alone. Always activate in multiple steps, side to side, or front to back. In a 4-jack system, operate stabilizers in parallel. When stabilizers have made contact with the ground, the driver operator should alternate between sides to raise vehicle to its working position as close as level as possible. With the jacks fully extended, the apparatus should be level and ready for operation of the aerial device. Amount vehicle is to be raised depends on manufacturer's design. Some stabilizers designed to have all apparatus tires lifted off the ground. Some designed to lift only rear tires. Others designed so all tires remain on the ground. For exact recommendations, personnel should refer to the owner's manual of the apparatus. Stabilizing using fulcrum-type stabilizers, or those that extend straight down from the chassis, is similar to box-type stabilizers. The primary difference is the driver operators can only deploy fulcrum-type stabilizers in fully extended positions and not at all if obstructions are present. The method for deploying the fulcrum-type stabilizers is the same as described in the box-type with one exception. The fulcrum stabilizer should be lowered to within a few inches of the ground prior to the placement of the stabilizer pad, which allows for correct placement of the pad. Some apparatus allows for partial extensions of the stabilizer arms, sometimes called short jacking. When operating in a restricted area, fully extend the extension arms on the side of the aerial device is going to be over. Extension arms are on opposite side as far as possible. Load and range of safe movement capabilities significantly decrease if the extension arms are not fully extended to their maximum position. Consult apparatus manufacturer's directions for recommended procedures. Whenever possible, a safety officer should observe aerial operations when short jacking is in use. In some situations, setting up on uneven terrain is unavoidable. When necessary, the driver operator is required to make apparatus as stable as possible, realizing operation of the aerial device may be somewhat limited compared to operation on level ground. Two ways trucks can be uneven: lateral, which is side to side, or longitudinal, which is end to end. When stabilizing on uneven terrain, lateral unevenness is typically easier to correct. Correction of lateral unevenness is possible on grades up to 5 degrees, although this can vary depending on the aerial device. The slope of 5 degrees means there is a rise in terrain of a height of 5 feet for every 100 feet in distance. Most manufacturers of aerial devices recommend lowering the stabilizers on the uphill side of the vehicle first, although some may specify opposite. Stabilizers should be lowered only until solid contact with the ground is made. Lower downhill side stabilizers until they raise the downhill side of the truck level with the uphill side. The driver operator must make sure to raise the truck enough to activate the interlocks if the apparatus is so equipped. If interlocks have not activated, it will be necessary to raise both sides of the truck until they do so. After the apparatus is stabilized, preferably to operate the aerial device over the uphill side of the apparatus. If this is not possible, consider lessening the amount of aerial device extension and loading based on the manufacturer's recommendations. Operating on a longitudinal or end-to-end grade is a little more challenging than on a lateral grade. When setting up on a longitudinal grade, position apparatus to minimize stress on the aerial device due to the grade. Operate the aerial device either directly over the front or rear of the apparatus, depending on whether the apparatus stops short of the object or past it. Unless the situation is unavoidable, do not place apparatus crosswise on the grade. Operate articulating devices off the rear of the vehicle once this is possible. Use stabilizers to level the apparatus as much as possible. Always make sure to check manufacturer's recommendations for aerial device loading on grades. Most have restricted loads when operating on grades, some as much as half of the normal load. If in the red zone or the unsafe load, do not operate the aerial device. Whenever possible, the driver operator should avoid placing stabilizers on curbs, sidewalks, parking lots, water valve covers, and other similar obstructions. Surfaces may not support weight of the stabilizers and may collapse. Some concrete construction is not reinforced with rebar, and curbs cause unnecessary unevenness of the stabilizers. These situations should be treated the same as setup on a lateral incline. Lateral incline load and extension restrictions also apply in this instance. Pre-incident planning will help identify areas that are safe and unsafe for apparatus placement. Err on the side of caution. The driver operator should always ensure that objects or ground surface upon which stabilizers are resting is solid and capable of supporting the necessary weight. Uneven roadways, sand, gravel should be avoided. If objects are already damaged or weakened, they are not candidates for the weight and the stress that the apparatus will place upon them. Rather than deploying stabilizers on an unsafe, potentially safe surface, reposition the apparatus. In cold weather conditions, the driver operator should be alert for icy patches or frozen ground as potential problem areas. Ice reduces stabilizers' ability to make solid contact with the ground. Avoid ice as possible. Frozen ground can also melt from apparatus exhaust or water runoff and leave an area unreliable for the surface of the stabilizer. One effect of ice melting is creation of an air gap between the stabilizer pad and the ground, compromising stability of the apparatus. The driver operator must constantly monitor the stabilizers and be prepared to lower them further for maximum contact with the ground. When the ground is frozen solid and the surface is on an angle, aerial device can move or chatter along the surface due to the combination of vibration and gravity. Operators can prevent this through the use of wheel chocks, sand, or other friction-enhancing products that can be carried aboard the aerial device to assist in the secure planning of the stabilizer. Avoid using salt, since this may melt the ice or snow and reduce the contact of the stabilizers. After fully deploying the stabilizers, the driver operator must ensure that they are locked and will stay in place. On most aerial apparatus, a combination of interlocking features of the selector valve and hydraulic system holding valves provide automatic locking capabilities. Interlocks prevent the flow of hydraulic fluid into or out of the stabilizing system while the aerial device is in use. Holding valves prevent movement of the fluid within the stabilizing system. The driver operator activates holding valves by moving the selector switch to the aerial position. On some older hydraulic systems, it may be necessary to set holding valves by operating stabilizer controls once in each direction after moving the selector valve to the aerial position. Many new apparatus is also equipped with an indicator light that shows when the interlocks are engaged. Apparatus may also be equipped with a sight gauge level that allows the driver operator to easily determine if the apparatus has been raised evenly. Some apparatuses are equipped with a box-top stabilizer that has a series of holes drilled through the bottom post of the elevating jack. The holes are designed for the insertion of a large steel pin that acts as an additional safeguard against inadvertent dropping or drifting of the jacks. Once the apparatus is in the desired position, the pins should be inserted in the holes immediately below the jack housing if equipped. When the use of the aerial device is complete and it is returned to the bed, stabilization process is reversed in order to prepare the apparatus for the departure from the scene. With the aerial device properly bedded, the driver operator should remove safety pins from the jacks if equipped, return the selector valve to the stabilization position, move wheel chock slightly away from the tires at this time as an extra precaution to not set apparatus directly on top of them or on both of them. The driver operator should also check entirely around the apparatus to make sure that all personnel and equipment are clear of the apparatus before retracting the stabilizers. After completing these steps, the stabilizers may be raised. The driver operator should always raise the stabilizers following the reverse order by which they were deployed. Following the reverse order avoids undue stress on any component of the aerial apparatus. Once the raising procedure is complete, return the selector valve to the neutral position and disengage the PTO system. The driver operator should return stabilizer pads to their appropriate storage locations. Working at heights inherently involve risks, greater when working on a device with moving parts that extend, retract, raise, lower, and rotate. It's essential that fall protection equipment be provided for any personnel who will be climbing the ladder or riding in the platform. Fall protection features include aerial ladders with handrails, platforms that include railings and gates. Each operator on the device should be equipped with a fall-resistant ladder belt and tether meeting the NFPA 1983 standards. Fall protection only useful if the tether is secured to a portion of the device that will support the load imposed by a fall. Use only structural features of the ladder or platform for anchor points. Never use a feature that will allow clip to slide more than a few inches. Never anchor onto any feature that is not a permanent structure of the device. Do not anchor to cables, wires, lights, or any other features. If you fall while tethered, you may hang without the ability to climb back onto the device. People can only hang briefly before blood circulation is cut off and they begin to have issues. Most ladder belts and tethers are not designed for self-rescue. Prepare a plan that will ensure personnel who become hung from safety ladder belts and tethers are rescued immediately. Never operate the ladder or platform device while alone. Position the aerial device first before allowing personnel to climb or descend. Climb or descend carefully, maintaining 3 points of contact at all times with structural features. 1 hand, 2 feet, 2 hands, or 1 foot. Place feet on rungs only. Anchor safety tether to a structural feature anytime you pause in your climb. The aerial operator is responsible for the safety of people and device when it's in motion. Never rotate, elevate, or lower the device with people on the ladder unless they are securely attached to a structural feature of the ladder using an approved safety ladder belt and tether. Starting, stopping rotation can cause the device to jerk, making it more difficult for personnel to hang on. Rotating the aerial device with unsecured personnel on the ladder puts their lives at risk. Maintain communication between personnel and always notify personnel on the device before moving it. Never extend or retract the device with people on the ladder. Extending and retracting the ladder creates pinch points, crush hazards as rungs, handrails, and other members of the ladder section moves past each point. Modern platforms are equipped with railings and gates to improve safety of personnel riding the basket. Railings are not sufficient to protect occupants in adverse conditions. Lives have been lost when baskets have caught momentarily on the edge of buildings, snapping back and launching personnel over the railings. All personnel riding in the platform must be tethered to a structural feature of the platform or an approved anchor at all times. Anchor the tether as soon as you enter the basket and only unclip just prior to leaving. Never set the platform device in motion unless all riders are securely tethered to the platform. All fire department aerial devices have levers or control devices the driver operator uses to make the device function. Controls may differ from among apparatus to apparatus. The driver operator is fundamentally a technician who must be well trained in the location of each of its control features, its functions, how it operates, when it should be used, and appropriate safety precautions. During aerial device operations, it may become necessary for other members of the department to communicate device movement instructions to the aerial operator. These instructions must be clear and consistent. They can be a combination of standard verbal and hand signals. Always follow SOPs for commands when they differ from the commands recommended here. The driver operator should also understand the functions and operations of all stabilizing power and safety devices. The driver operator must know limitations of the apparatus, proper spotting angles, maximum load limits, safe operating practices. The driver operator must have skills necessary to solve tactical problems at the incident, operate all controls while maintaining visual contact with the aerial device and the space within which it's moving. If visual contact cannot be maintained, then an operator must rely on a spotter. The driver operator must be well versed in layout and operation of the aerial device controls. Early portions of any training program should be dedicated towards this goal. If the driver operator will be expected to drive and operate more than one type of aerial apparatus, he or she must be trained on each of the different apparatuses. Some aerial devices may be operated from multiple locations. Primary control position for an aerial operator at the lower controls, usually located at the turntable. Trained and authorized aerial operator must staff this location at all time the aerial is in operation. The operator is responsible for the safe operation of the device and the safety of the personnel near the device. When working from the primary control position, the operator must be aware of the number, the weight, and the position of the personnel and equipment on the device. Monitor the weather. Monitor the water flow. Maintain two-way communications with the personnel at the tip or on the platform of the basket. Observe personnel on the turntable who are helping observe the situation, who are waiting to ascend. Personnel should keep well clear of the ladder at all times. In the secondary control position, either at the upper tips, the controls, or on the platform in the basket, anytime there is a firefighter operating these controls, must also be trained and authorized aerial operator at primary control position as well. The secondary control operator performs the final positioning of the aerial ladder during the rescue or other firefighting operations. Controls do not replace lower controls as primary positions for the aerial ladder. When the tip control is used, the operator at the tip of the ladder needs to take the following precautions. Be aware of personnel who are on the ladder sections behind them. Take care to place feet on the steps at the tip to avoid injury from the moving ladder sections. Be belted in position to protect against abrupt or unexpected ladder movements. Be aware of impending water flow and monitor the tower reaction. Be aware of electrical hazards and other obstructions. Ladder capacity ratings are established for many different operating positions other than fully extension and 0-degree elevation. Ladders are often rated at higher tip capacities as elevation angles increase or when the ladder is not fully extended. Most manufacturers provide distributed load capacities depending on the ladder's extension and elevation for several people. This information is communicated via the load chart. Combination ratings that include capacity at the tip while discharging water are also normally provided. Ratings can vary with the elevation, and the extension are examples of multiple configurations. The aerial operator must study the load chart and be aware of the operating parameters. Raising the device means elevating the entire assembly from its stored position to a desired angle and useful position. The overall process of lowering the aerial device is typically the reverse of the process used to place the device into position. Considerations must be given to whether or not the waterway has been used and the nozzle has been returned to the stowed position. When the aerial device has been lowered and stowed, stabilizers may be raised, power takeoff may be disengaged, fire pumps disengaged if so equipped, and the truck readied for road travel. Aerial ladders with piped waterways and water towers may be equipped with remote controls that allow the driver operator to manipulate the fire stream from the aerial platform control pedestal, pump panel of the apparatus, or from a remote control box or wireless controllers. Typically, using these controls, the driver operator can change the fire stream pattern and direction. It is always most desirable to operate the nozzle with the remote control if available. This eliminates the need to place a firefighter in a hazardous position on the tip of the device, may free a firefighter for more effective use elsewhere on the fireground. In some cases, activating a nozzle remote control is possible while operator is moving the aerial device into position. True pinnable waterways are permanently attached nozzle systems that can be operated from either the tip of the aerial or one section or fly lower. Operators of pinnable waterways must be properly trained and have full knowledge of the proper procedures for safely operating in both firefighting and rescue modes. Firefighting mode is the master stream nozzle is at the tip of the aerial. Rescue mode is the nozzle is one aerial section lower. If a manual stream change is necessary, the firefighter should wear full PPE and an SCBA. Climb to the tip of the ladder, attach to the ladder using an approved safety ladder belt, change the stream to the desired position, immediately descend the ladder, elevator platforms are preferable to use some type of elevated platform apparatus when placing one or more firefighters at the position where the elevated master stream is going to be deployed. Elevating platforms provides a safer standing position for firefighters operating the stream. Many elevating platforms also have piped breathing air systems which allow firefighters to breathe clean air for extended periods of time. Also have an NFPA required heat shield and a protective water curtain or cooling spray nozzles beneath the platform that can be used to cool air in highly heated temperature atmospheres. Lastly, Elevating platforms have their own control panels allows firefighters at the tip of the device to move should they need to do so for the safe and operational purposes. Operation of the aerial device when apparatus is parked on a grade greatly complicates the dynamic stress factors placed upon the aerial device related components. Situations in which the floor of the platform and/or the knuckles between the boom are not parallel to the ground can result in a twisting force on the entire aerial device system. Aerial devices are not designed to routinely handle this type of force. The driver-operator must be conscious of these limitations in conditions and situations and have the knowledge of the limitation of the particular aerial device in use. The following are keys to safely and effectively operating on a grade: optimal position, proper stabilization of the apparatus to counter increased risks, load restrictions for the given grade. Cold weather presents several special considerations for aerial driver operators. Causes an increased viscosity of the hydraulic oil, slowing the overall machine operation. Less obvious effects of cold weather include physical change in the properties of the metal structural members of the device. When subject to extreme cold or sub-zero temperatures, the device should be operated in a manner that will minimize or eliminate shock loading to its structural members. Because the aerial device is often operated near a fire, the device may occasionally come in contact with superheated air or, on rare occasions, direct flame contact. The driver-operator should be continually aware of the surrounding conditions the aerial device is in and the personnel operating on it. Should be prepared to reposition the device when the danger of the exposure to the device is extreme. If an aerial device cannot be moved immediately, water streams should be applied to the device to keep it cool. Heat damage to the aerial device may or may not be visible. Some signs of damage is discoloration, disfiguration, deformed welds, improper operation of the aerial device, heat sensors that has changed color on the aluminum apparatus. If the damage is noted or suspected, an emergency vehicle technician should repair the apparatus. The apparatus should be given a thorough operational test before being placed back into service. The operator must continually be on the lookout for any of the following signs of mechanical failure or troubles: leaking fluid, leaking hydraulic fluid, leaking fuel, leaking water from the engine or cooling system, leaking motor oil, overheating of any mechanical component, unusual noises or vibrations, drifting of the aerial device when raised, gauges indicating abnormalities, odor of burning fluids, interlock failure, unsafe drop in the voltage of the electrical system with possible alarms. If any of those indicators are present, remove personnel from the device immediately, bed the device, and immediately take the device out of service. Prolonged operations under adverse environmental conditions can cause the hydraulic oil to rise in temperature beyond its recommended temperature range. High oil temperatures can lead to premature equipment failure. Monitor the hydraulic oil temperature, especially in high ambient conditions or during lengthy operations. If high temperatures are encountered and the emergency conditions allow, consider shutting the PTO off for a period of time to give the oil a chance to cool down. Failure of the main hydraulic pump will typically require auxiliary hydraulic pump to be used. Only operate the auxiliary hydraulic pump in intervals as recommended by the manufacturer. This will prevent overheating of the auxiliary electric motor or hydraulic pump. Before activating the hydraulic auxiliary pump, ensure an aerial control lever is positioned to allow for the hydraulic fluid pressure to flow. Before placing the apparatus back into service, the aerial device should be repaired by EVT and thoroughly tested. If involved in an incident where damage to or failure of the aerial device occurs, the driver or operator may be called upon to provide information about operating conditions. Weather, load, or emergency factors should be noted. Information will greatly aid any professional reviews of the incident to determine exactly what caused and led to the failure. Below grade operations. In some instances, it may be necessary to deploy the tip of the aerial device to a location that is below the level in which the apparatus is parked. Aerial devices may also be used to support other operations being conducted below grade, without actually having to place the tip of the device that low. Before attempting this type of operation with any aerial device or apparatus, consult manufacturer's operations guide to be assured whether or not the device can safely, properly deploy below grade. There are a variety of situations that may be required for below grade operations. Special rescue operations, creating a high point anchor for a rope rescue system that moves a load, deploying a master stream to below grade locations. Follow these general safety guidelines during apparatus inspections and maintenance and testing. Ensure any chassis and device is inspected in accordance with NFPA 1911. Perform daily inspections between each shift per SOP. Ventilate the area and wear PPE when inspecting batteries. Stay clear of moving or rotating parts. Stay clear of hot surfaces. Follow these general guidelines when preparing to drive the aerial apparatus. Thoroughly read and understand the operator's manual. Enter, exit, and work on apparatus using 3 points of contact method. Adjust the seats, the mirrors, the pedals if applicable, and steering wheel to fit the driver. Secure all exterior compartment doors, ladders, and loose equipment. Secure all stored hose using approved hose restraint devices and methods. Secure all interior compartment doors, loose equipment, and SCBA packs. Ensure all occupants are seated and belted. Secure aerial device in the cradle and stow all stabilizers. Ensure axle weights do not exceed their gross axle weight rating. Drive only if trained, licensed, and authorized. Use a spotter when backing. Drive at speeds appropriate to the conditions. Watch for low bridges and overhead obstructions. Obey all traffic signals. Look ahead and anticipate need for brake or maneuver. Turn off auxiliary brakes and reduce speed in inclement weather. Always use a spotter. Position only where apparatus can be set up on a firm surface. Position only on slopes that do not exceed manufacturer's recommendations. Position so that the aerial can reach the final position without exceeding its reach and capacity. Position on one corner of the structure when possible and applicable. Do not position where exposed to falling debris. Always use warning lights when positioned in traffic. Never position on railroad tracks or an active runway. Operate controls from the operator's platform, not from the ground. Only use secondary operator at the tip if absolutely necessary. Never operate from the tip without primary operator at the main controls. Primary operator must be prepared to override the tip operator if unsafe conditions are encountered. Communicate with personnel on the device before moving. Never exceed load chart limits of operation. Never extend or retract with personnel on the ladder. When approaching a structure, always finish by lowering. If ice forms on the device, follow reduced capacities per manufacturer's instructions. During icing conditions, clear all personnel from beneath the device, especially during operations. Cease operation if winds exceed manufacturer's limits. Adjust operating limits if short jacking. Keep aerial device, vehicle, and personnel at the recommended distance from power lines. Never make contact between the device and a structure. Never position over high heat or open flames. Do not position over roof if there is danger of sudden roof ventilation. Follow these general guidelines when climbing or riding in an aerial apparatus. Always use an approved fall protection equipment. Climb, ride, and work on apparatus using 3 points of contact. Stay clear of swinging structures and other moving parts of the aerial device during operation. Never hold on to the ladder handrails, rungs, or lacing while the aerial extending or retracting. Follow these general safety guidelines for water management on an aerial apparatus. Account for reduced personnel capacities when flowing water. Open or close master stream valves slowly. Make directional changes of water streams slowly and smoothly. Drain pre-piped waterways prior to extending or retracting. Open drain or bleeder valves before removing intake or discharge caps. Drain waterway before retracting. Drain water from waterway before stowing in freezing conditions. Follow these general strategies and tactics for safety. Approach rescue victims from upwind. Aim above rescue victim and then lower the device to them. Avoid loose or falling debris when operating near unstable structures. Watch for possible structural collapse from water weight. Never anchor working end of pulled rescue rope to or other parts of the apparatus, static structure, or objects on the ground. Effective communication allows for early and correct aerial placement. More efficient aerial operations throughout the incident. Successful communications for aerial operations include pre-arrival communications, on-scene communications, and tactical communications. Pre-arrival communications include specific information about the initial phase of the incident. Officers and driver operators will communicate on direction of approach, decision to stage or commit the vehicle, water supply. Incident commanders communicate apparatus positioning and overall aerial objective. On-scene communications, officers and operators size up, confirm water supply strategy, apparatus location and turntable placement, hand signals and/or communication devices systems as dictated by SOPs, directions to guide operator to exact position quickly, safely, and efficiently. Tactical communications, aerial deployment, hand signals, guide aerial ladder into position, direct master stream at target if being used. Aerial operations, use of headsets enable calm and clear communications without disrupting emergency scene communications. Pump panel operator, control pedestal operator, and if required, a firefighter at the tip. The aerial device offers access to upper levels. Access can be used for many strategies and tactics: rescue, ventilation, elevated fire attack, firefighters' tasks such as emergency escape and equipment delivery. When fire conditions do not allow victims to be brought down interior stairs or exterior fire escapes, it may be necessary to use an aerial device to get them down. Firefighters involved in rescue operations must always be aware of weight limitations. Overloading aerial device in a rescue situation could lead to a sudden failure of the device, resulting in injury or death to anyone involved. The best rescue approach, made from upwind on level grade and without obstructions. The apparatus should be parked so the aerial device turntable is upwind of target. If approach is made from downwind, the aerial device may be enveloped in smoke, exposing personnel to toxic smoke and inhibiting vision. If possible, the driver operator should position the aerial apparatus used for rescue at a corner of a building. Advantages: can potentially reach victims on two sides of the building, potentially safer on the corner of a structure if a collapse occurs. If a rescue is made from an area threatened by fire, hose lines can be used to protect victims, rescuers, and the aerial device. If protective hose lines are needed, caution must be used when selecting fire streams. Solid streams or straight stream master streams directed against an aerial device can place damaging load stresses on the device, could ultimately result in a collapse of the device, especially if other factors such as wind or icing conditions are present. Preferred procedure: use a wide-angle fog stream to cool and/or protect the aerial device and the personnel while rescue operations in progress. Use caution to avoid injuring people or compromising their balance while on the aerial device. Plan for getting a victim into platform will determine placement of an apparatus equipment with the elevated platform. If a victim is to be lifted over the top rail, the driver operator should position the apparatus so the turntable is directly in line with the target if possible. This allows front of the platform to be positioned squarely in front of the target. If the victim enters the platform through the hinged gate, the turntable must be positioned a little forward or behind target because of platform gates are typically on the side of the platform. The device must be raised at an angle to target to provide safe access to the gate. The best position. The extended and rotated aerial device is perpendicular to objective. In the perpendicular position, twisting stresses imposed on an aerial are reduced. If an aerial ladder is designed to be used in unsupported position, tip should be placed above the target spot according to manufacturer's recommendations. Prevents ladder from contacting with the building as people climb or descend without placing excessive stress on the device. In older apparatus designed to be used in supported positions, perpendicular positioning allows for maximum load carrying capabilities when both base rails are evenly in contact with the supporting object. In many cases, optimum positioning is not possible. Aerial ladders must be extended toward the object spot at an angle. Extend ladder so beam on building side of the ladder is above and over the object. When victims board the ladder, their weight will cause the ladder to flex. Proper positioning will prevent the beam from contacting the objective. If the beam is contacting the objective, weight of the victims can cause opposite beam to bend downward, which could twist or bend the ladder, causing catastrophic failure. When maneuvering an aerial device to reach a victim trapped in an elevated position, the aerial device initially should be aimed above the victim and then lowered. If the aerial device is raised beneath a panicked victim may jump for the tip of the ladder or platform on approach. Victim's action could injure the victim, or a firefighter could potentially damage the aerial device. The rescue firefighter should be prepared to climb the ladder. Instruct victims on how and when to aboard the device. Instructions may be in the form of hand signals, audible instructions, or both. Placement of the aerial device tip is important consideration when victims are to be removed from interior of buildings through a window. The aerial tip must be positioned so that the area of the window opening is not diminished, yet safe access to the aerial device is provided for both victim and firefighters. When using the aerial ladder, the first rung of the ladder tip should be placed even with the window sill. In this position, ladder will not block much of the window opening, also allows firefighters to place victims directly on the ladder with a minimal lifting. When using aerial platforms, most fire departments prefer platforms be placed so top rail of the platform is even with the windowsill. Victims can board directly into the platform feet first. Alternative is to position the platform so the access gate through the platform railing is adjacent to the window opening. Open gate and assist victims entering the platform. May not be possible depending on the design of the aerial platform. When removing trap victims from a roof or other similar opening flat areas, the aerial tip of the ladder should be placed so that at least 6 feet extends above the edge of the roof line. Aerial platforms should be placed so that the bottom of the platform is just above and over the edge of the roof. Position allows victims to have a handhold while climbing onto the ladder or into the platform. Placement of the aerial device for rescue from balconies with railings or roofs with parapet walls should follow the same guidelines. When rescuing victims Off of parapet-style roofs, it may be necessary to use a roof ladder to get over the parapet to the aerial device. The aerial device should only rest against the target if manufacturers approve supported operations. If the parapet is structurally sound, the roof ladder should rest against the parapet rather than the ladder. Once the aerial device properly positioned, rescuers may remove victims from the structure. Techniques used will depend on the type of aerial device and age or condition of the victims. After properly positioning the aerial ladder, at least one and preferably two firefighters should be assigned to assist victims in boarding and descending the ladder. When two or more firefighters are available, one should assist the victim from inside the building while the other remains on the tip of the ladder. If only one firefighter is available, situation will dictate whether it is better for the firefighter to be on the ladder or inside the structure. Capable adults should be guided down the ladder under their own power. Firefighters should always lead adult victims down the ladder. Small children and adults incapable of climbing down the ladder by themselves will have to be carried or supported. Only use this method as a last resort tactic when all other means of egress have been ruled out. Rescuers may cradle infants and small children in one arm, while the other arm is used to assist with balance stability while descending the ladder. When possible, a desirable method may be the knee set method, best used for a heavier person who is conscious, able to control his or herself's movements, but strong enough to descend under his or her own power. Also beneficial in that a smaller firefighter can easily carry a heavier person down a ladder. A second method is useful for unconscious or severely injured victims who are not able to physically assist in their own rescue. Position victims across rails of the ladder with firefighters supporting from below. Best position for the victim is the one that will be the most comfortable for him or her. Position may be face up, face down, or on their side. Place both hands under the victim's body and grasp the handrails. The firefighter's arms secure the victim. This method poses little to no risk to fall. The over-the-shoulder carry is the most difficult and the most risky since firefighters will only have one hand available for stability while descending the ladder and will be bearing entire weight of the victim. Rescuers should only perform this carry with a safety firefighter descending just below the firefighters carrying the victim. To perform this carry safely, a firefighter inside the building should assist with loading the victim onto the shoulder of the firefighter. Using the aerial platforms to move victims is considerably easier than backing them down aerial ladders. It is slower, it's not suited to mass evacuations from a single point, when only an aerial platform is available for multiple rescues. If need be, can be used much the same as an aerial ladder rescue. Decisions must be made by a qualified person, whether the incident commander or the firefighter in the platform. Which item should be used for the rescue operation, the ladder or the platform? Instructions for lowering passengers into the platform. Load capacity of aerial devices and space inside the platform will determine the number of passengers who may be lowered into the platform. Do not exceed the aerial device's load rating. One firefighter then lowers the aerial device to the ground to unload the victims. The second firefighter, if available, should remain at the loading point to calm and reassure remaining victims while the platform is being unloaded and returned to the rescue. To remove unconscious victims, two firefighters are required to remove unconscious victims. At least one firefighter will have to lift the victim from the structure to the platform, while another firefighter waits in the platform. If a victim is not on a Stokes basket, set or lay the victim in the floor of the platform. Lowering a Stokes basket using an aerial device. If victims are unconscious or injured and able to move themselves, may be necessary to evacuate them down an aerial ladder by the way of a basket-top litter. This tactic should be used as last resort since it's much easier and safer to carry a litter down a stairwell, fire escape, or move it to a safe place of refuge until conditions improve. When not able to carry a litter down a stairwell, two methods of lowering a Stokes basket by the way of an aerial device. The easiest method is to slide the basket down the ladder using one of the two methods. The best method works only if the litter will fit between the rails of the aerial ladder. In this case, the litter is simply placed on the rungs of the ladder with the victim's head up. If the litter does not fit between the rails of the ladder, it should be placed on top of the handrails perpendicular to the ladder. If this method is used, a guide rope from the top side should also be used to help control the descent of the ladder. Some departments also prefer to secure two long handled tools such as pike poles to the bottom of the litter to assist with the slide. Some aerial devices may be equipped with a lifting eye. This may be used for rescue operations. For the use of the rope type rescue operations with limited capacity for the eye, to ensure capacity is not exceeded, the lifts must be made in a smooth manner without causing the device or load to bounce, jerky, or sway. Using the aerial device for water rescue, the two most common scenarios include vehicles driven into high water across the roadway and removing people from being trapped on a tree, a similar object in a rain-swollen, fast-moving body of water. There are several safety issues that affect the use of the aerial apparatus during water rescue. Often a lack of suitable location to stabilize the apparatus, potential for the aerial device to make contact with swiftly moving water. The aerial device is not designed to handle excessive lateral stress. The aerial that have a low tip load rating when fully extended to horizontal objects can become overloaded. An aerial device can also assist in ventilating the fire building, used to place firefighters on the roof or provide access to upper story windows. Proper aerial placement can make ventilation processes easier and quicker and safer. Position apparatus on unburned side of the structure as close as possible to the area being ventilated. If firefighters can't safely operate on a roof or if the other conditions warrant a different approach, horizontal or cross ventilation can be accomplished with the aerial device. A firefighter on the tip of a ladder or platform can break upper story windows with a pike pole or similar tool. When operating in this manner, the firefighter doing the ventilation should be secured to the ladder or platform with a safety belt. The aerial device should be positioned slightly above the window and slightly upwind side. If a wind is blowing across the face of the building, windows on the downwind portion should be taken out first using proper ventilation practices. By taking a position slightly above a window, firefighters is not subject to falling glass. Elevated master streams, most commonly used in defensive operations, directly attack the fire, cool embers and gases within the thermal column, and protect exposures. When a defensive attack is employed, risk of building collapse must be considered. Positioning the apparatus at the corner of the building or at an otherwise safe distance from the building decreases the chance of damage to the truck and injury to firefighters in the event of a building collapse. Chances of damage from radiant heat from the fire as well. Safe distance must be balanced with a close enough distance to allow bulk of the fire stream to reach the seat of the fire area or exposure being protected. When an incident commander makes the decision to apply water from an aerial master stream, the driver operator needs to know volume to be delivered, type of stream to be used, placement of the stream. The driver operator is responsible for applying water streams as quickly, smoothly, and efficiently as possible. If the driver operator has not given consideration to potential water supply demands on the initial setup, then all of the water that is available from the hydrant may not be used and the stream will be ineffective. When using an elevated master stream in a blitz attack, the driver operator should position apparatus to give fire streams as much reach into the fire area as possible. The ultimate goal, to place the nozzle in a lower portion of the window opening so the fire stream may be directed upward towards the ceiling. The driver operator must ensure that the apparatus is close enough to the building so the tip of the aerial device can be placed into the desired position without allowing radiant heat to cause damage to the aerial device and the apparatus. In some cases, aerial devices may be used as a master stream closer to ground level, especially if the apparatus equipped with water towers and telescoping aerial platforms. The driver operator should position apparatus so the turntable is directly in line with the intended target if possible. Position allows fire streams to penetrate as far as fire area as possible. In addition, the driver operator will need to judge distance to building accurately so the nozzle will get close enough to be effective. Nozzles. Both solid stream nozzles and fog nozzles have their respective place in an aerial operation. If possible, both types should be carried on apparatus and be available for the use from the aerial. It's important to ensure any nozzle used are compatible with manufacturer's designed waterway and appliance provided with the truck. Will prevent damage to the waterway and poor stream or flow performance when appliance is in use. Regardless of the type of nozzle chosen for the operation, it's imperative that the nozzle be provided its rated flow and pressure. All nozzles lose some effectiveness when not discharging their rated flow. Fog nozzles provide wide coverage than solid stream nozzles, able to break up water to allow better steam conversion. The drawback: do not provide reach penetration often needed to reach the seat of the intensive fire. Fog streams may be also adversely influenced by atmospheric or fire-created winds. In very intensive fires, water from a fog nozzle may be converted to steam before reaching the seat of the fire. For most defensive or otherwise long-range operations, set fog stream nozzle to straight stream setting in order to closely emulate the performance of a solid stream nozzle. Solid stream nozzles provide excellent penetration into fire areas. If an outside elevated stream is to be directed into the interior of a structure, nozzles can provide power needed to reach the seat of the fire while allowing heated gases to vent around the stream. Solid streams are not affected by wind conditions, nor are they as effective for rapid steam conversion as fog streams. Solid streams also are able to reach longer distances when apparatuses cannot be positioned close to the building. The best applications for solid streams are reaching fires deeply seated within a building or for defensively attacked large fires with well-developed fires from a relatively long distance. Aerial apparatus can be used to apply large quantities of foam if available to flammable and combustible liquid fires, bulk storage fire tanks, aircraft, industrial facilities, transportation incidents. Generally not practical to discharge aerated foam through an elevated master stream appliance. Aerated foam has a very high air content within that stream. The blitz attack. Carefully place solid or straight stream master streams from exterior of the building. Elevated master streams can make a blitz attack if conditions are right, personnel are trained appropriately. Apparatus must be able to position fairly close to the building. The seat of the fire must be located where an outside stream can reach it. Often conducted when fire is on upper stories while firefighters are preparing to enter the building. The best way to an effective blitz attack with an elevated master stream is to deflect water off the ceiling of the fire room. This can be accomplished by positioning the aerial device so the nozzle is about even with the bottom of the window. Position allows water to enter the area at an angle of about 30 degrees. Water will hit the ceiling and deflect to the seat of the fire. If too large of an entry angle is used, water will hit the ceiling ahead of the fire area, cascade to the floor. The defensive attack is the more commonly used of an elevated master stream in defensive operations. Defensive attack, an exterior attack with the emphasis on protecting exposures. The object of a defensive attack is to contain the fire within a specific area. Consider the indicators of a potential defensive attack. Fire or building conditions that prohibit safely advancing hose lines into the building. Incident commander opts to sacrifice part of the building to the fire. Large amounts of water needed to extinguish the fire, common attics or multiple apartments, etc. The fire conditions at incident will dictate what type of stream should be used. Most commonly, a solid stream or straight stream will be required to reach the seat of the fire. Because intense heat of the fire could cause the force apparatus to be positioned farther away from the fire, and/or the fire may tend to convert a fog stream to steam before it reaches the hot seat of the fire. When trying to stop the spread of fire through a single building, care should be taken not to push fire into involved areas. Power of the elevated streams can cause furniture and other burning items to move to unburned areas, as well as create avenues of convection of heat. Movement of burning building contents can cause a change in the direction of fire spread and even reverse rise of products of combustion in thermal columns. If possible, position the apparatus on the unburned side of the building. This allows the master stream to push fire and convection waves away from the unburned portion of the building. Not common for more than one elevator master stream to be used at large defensive firefighting operations. Driver operators or firefighters who are operating streams should exercise caution so they do not strike another aerial device with their own stream. Carelessness with fire streams could injure firefighters working at the tip of the other device. Could also cause damage to the other aerial device. Using the aerial as an exterior standpipe to upper floors is an attack that can eliminate difficult hose lays up interior stairwells. Interior hand lines can be provided by removing the nozzle and attaching hose lines to a gated outlet. Operations may be necessary when an interior fire on an upper floor and building does not have an operable standpipe system. Using the aerial as an exterior standpipe is also an effective tactic for fires in parking garages, building roofs, bridges, and overpasses, in buildings under construction where a standpipe system is not available. Many aerial devices provide outlets for hand lines on the device itself. With these outlets, hand lines can be pre-connected and kept in the platform, saving valuable time in setting up for interior standpipe operations. Adding pre-connected lines to the platform temporarily reduces the amount of additional weight that can be added to the platform. Using the aerial device as an elevated standpipe commits ladder or platforms to a single position. May prevent its use for other critical tasks such as rescuing or ventilation. Careful evaluation of incident priorities will help determine if the use of this tactic is beneficial or if the aerial device will be better used for other tasks. Exposure protection. An exposure is a structure or separate part of the fireground to which the fire may spread, such as a carport, automobile, a stack of hay, another building. Fire spreads to exposures either by conduction, convection, or radiation. Conditions that may affect exposure hazards include weather, fuel, topographical, building construction, spaces between the fire building and the exposure, intensity of the fire. Both current and recent weather conditions affects a fire's ability to spread to other exposures. Both current and recent weather conditions affects a fire's ability to spread to exposures. Rain reduces the potential for fire spread. Wind enhances the effects of radiant and convection heat transfer and fast-moving burning embers. The type of the construction and proximity of the exposure to the fire building also affects the chance of the exposure catching fire. For example, exposures with combustible exterior finishes have an increased risk of the secondary fire involvement. Some combustible construction elements include wood or plastic siding, wooden window frames, and interior combustible items such as curtains, blinds, and carpet close to a large window or glass area. Closer exposures to the fire building more likely will catch fire. The apparatus must be considered an exposure hazard. It may be the most valuable exposure at the scene. Placement of apparatus is crucial to ensure it does not become a risk, because radiant heat can transmit through water. Simply directing fire streams into the air between the fire and the exposure will not reduce the chance of the exposure catching fire. Protection from convective fire spread can be accomplished by applying large fog streams into the thermal column. Streams may reduce chances of burning embers traveling through the air and igniting other combustible items. When resources are limited, it may be necessary to use one master stream to fight both the fire and protect the exposure. This can be done by positioning the apparatus so the master stream can be moved between the fire and the exposure. Be careful to not be negligent of the exposure by devoting too much attention to the fire itself. Some elevated platform apparatus are equipped with two nozzles on the platform. With two nozzles, one stream can be applied to the fire building while the other protects the exposure. Practice of the use of two nozzles from an aerial platform is dependent upon availability of water, required flow, the number of firefighters available to operate the monitor. Because of these factors, full use of the apparatus may be limited. Positioning the apparatus to provide exposure protection may create interesting challenges that require careful consideration. Planning must ensure apparatus position for effective safe stream placement and for maximum coverage of the fire and the exposure building if so desired. If fire is large enough to create exposure problems for other buildings in the area, apparatus assigned to protect exposure buildings may become exposures themselves. While desired to position the apparatus to provide maximum protection to exposed buildings, the apparatus should not be put into the situation where measures must be taken to protect the apparatus itself. You should always be a straightforward exit route in the event the fire conditions worsen and the exposure protection operations must be abandoned. The type of stream to use will dependent on the conditions of the individual fire. In exposure protection, wide sweeping nozzle patterns are generally used to cover involved area. Fog pattern allows for maximum coverage of the exposure. Fog streams may not work due to a variety of conditions. Then straight or solid streams may be necessary to absorb as much heat as possible.